my name is Christopher Britton, and I'm a PhD candidate in the Edge Lab. In the next few minutes, I will give you an overview of one of the research projects in our lab, Individualization for Quality Education at Scale. The recent and rapid rise of massive open online courses, or MOOCs, has created connectivity among students worldwide for the purpose of learning. Currently, there are over a dozen such MOOC providers. Let's take a look at some of the features of MOOC. These courses are online, free, or at least very cheap, have lecture videos, quizzes, and contain discussion forums. Importantly, these courses have a very large number of enrolled students, but with very low completion rates. This is a plot of empirical enrollment completion rate data for a variety of MOOCs in 2013, which emphasizes the scale-efficacy trade-off of learning. Even for those MOOCs operating at the efficient frontier of the trade-off curve, as enrollment increases beyond 50,000, it is rare to see more than 10% of students complete one of these courses. The question is, why are the completion rates so low? From our experience as MOOC instructors, we have identified two main factors. First is small teacher-to-student ratios. For instance, we observed significantly less than 1% over 73 MOOC courses offered in summer 2013. Second is the diverse demographics. Students have different learning backgrounds and different goals within a single course. The key is that diverse demographics render it impossible for a one-size-fits-all, or OSFA, course to work in a setting such as MOOC, where the teacher-to-student ratios are so small. Instead, we advocate individualized learning, where the course content can be different for each student, adjusted based on their individual desires and needs. In this way, we say that each course has different learning paths that a student can traverse, which is analogous to having a separate virtual tutor for the homogeneous group of students using each path. Our objective in this project is to design and continually update a platform to support course individualization. We call our system MIIC. Shown on the screen is the current user interface for MIIC. Let's dissect the acronym letter by letter. M stands for mobile. Currently, students access MIIC as a mobile app, as opposed to other adaptive educational systems which are either web or mobile web-based. The first I is for integrated. MIIC includes four modalities of learning: lecture videos, textbook material, assessment questions, and social learning, all in a single app. The second I is for individualized. MIIC adjusts the learning path for each student based on the user model, which is continually updated through data analytics. One can see on the current screens how each student has a different presentation of the given section, one with linear algebra and the other with basic algebra. Finally, the C is for course. MIIC is built for full course delivery rather than other platforms which are built only to serve as a supplement and do not include all learning modes. We will briefly walk through the individualization framework in MIIC. The three components, behavioral measurements, data analytics, and content presentation adaptation, are each updated sequentially in a dynamic feedback loop based on user interaction. Behavioral measurements refer to monitoring and collecting data about the user as she interacts with the course material. This is taken at fine granularity, allowing, for example, complete reconstruction of her video watching trajectory. The purpose of data analytics is to build and maintain a low-dimensional user model for each student, which is updated based on the measurements collected. Methods of implementing this could be simple, such as tracking assessment performance, or more sophisticated, such as applying factorization techniques to extract a latent space for the concept knowledge. Finally, the updated user model is mapped to the next set of content to be presented. MIIC supports two types of content adaptation: navigation level, which is determining which section of content to visit next, and presentation level, which is dynamically adjusting the content within the section itself. Recruiting a diverse set of students from MOOC, we've carried out two user trials with MIIC. In the first trial, users were given the same set of material in both MIIC and OSFA format, and were asked to compare their experience with each through a post-experiment survey. A number of the questions, such as which of the learning experiences led to a better understanding and which the students liked better overall, had high statistical significance in favor of MIIC. In the second trial, the objective was to measure student engagement, quantified here in two ways: as the total number of pages read and as the total number of text objects read. Students were given either MIIC or OSFA and were unaware of which they received. As one can see, the distribution is clearly shifted to the right for MIIC, indicating a higher level of engagement for both endpoints. Testing this difference also led to high statistical significance in favor of MIIC, with an estimated increase of 22% relative to the maximum page count of any student. Though our initial trials were limited in scope, the results were overwhelmingly positive, which has motivated us to investigate a number of next steps. First and foremost is more advanced data analytics to lead to more effective user modeling. We plan to apply more machine learning techniques, such as matrix factorization, hidden Markov models, and clustering, to help reduce the dimensionality of the problem and increase modeling accuracy. Second is to test content from courses other than ours. Third is to run additional trials with other metrics. Finally, we are extending development to other platforms. Thank you for your attention. If you have any questions, feel free to email me at cbrinton@princeton.edu.